So to take an example that, or a demo that is something that we didn't create, and talk about its performance. What we see here is a 60-second sequence, a 60-second capture from the Unigen demo, starting with when you see the dragons. At some point later on, we were kind of going down this road. And what we did was compute, I think this is the plotted average frame rate during each 1 second interval. Okay? So each data point here is the average frame rate across that 1 second interval. And then we also looked at the minimum and maximum frame rates within those 1 second intervals. And what we saw was that across this whole sequence, as sort of tessellation is being stressed, we slowed down to as slow as 35 frames a second, whereas ATI slowed down as low as 20 frames a second. So we're roughly twice as fast when things are being stressed the most. For individual frames of the sequence, we saw numbers actually much closer to 2. But
so this is just to interject on that. This is we talked about this a little bit earlier in the water demo, right? You don't want to, if you want a game developer to load up on geometry, you don't want them to have to worry that suddenly they're going to turn a corner and there's going to be some very beautifully, highly tessellated creature and the frame rate's going to suddenly fall off a cliff, right? You want to have a very good game experience where the frame rate is smooth no matter what's going on in the scene, and making sure that our tessellation and geometry performance is very high helps make sure that min frame rate stays very good no matter what's going on.
So are there any questions about what this data is yet? Because I didn't understand it initially. I was having trouble figuring what the heck it was capturing. So
not as such about what it is.
Okay.
If the developers of games use tessellation and you've got ATI's card listed there,
yes,
are they going to use the extra performance in your card easily to improve the quality of their games? Will we see any kind of improvement over ATI's product in yours, specifically coded into games?
So what I would expect to see happen is that games will design their engines such that they basically throttle LOD based on performance. So what you'll see is a game that's played on an NVIDIA part may have higher geometric fidelity than on an ATI part.
Yeah, there's an interesting, like with AA, right? You've had AA as the fastest knob, right? When you have a higher performance card, you can turn the AA up, right? An interesting option for developers now is to offer geometric realism as another knob. If you have a higher performance card, you can handle more of it, you can go ahead and crank that.
And one of the things that's nice about it, that knob is sort of a continuous knob. It's not like okay, you can have
So it's a
4x,
sliding
8x. Yeah, it's really a slider.
And it's completely programmatic, which is cool. It doesn't require any extra artist work, stuff like that. It's just a programmatic choice, which is a really nice feature.
Because of GX11.
That's right.
I think that's the key point. Because
Yeah, the way it's structured. Yeah.
has tessellation, as that geometry gets passed down, our tessellator can just continue to tessellate.
Yeah.
Well, one of the things which they said, which I want to stress a great deal, is we learned a lot from DX10, and one of the things we really want to make sure we did right with DX11 is make the new features really work well. If you don't make them work really well, they're just not going to get used, and then the world doesn't move forward. And you end up with a bunch of content that doesn't look that much different or better than the previous generation. And so with just this generation, we made tessellation work really, really well to give the best chance to developers to really use it, get a good benefit from it, and not have to pay some enormous performance price for it. It's a bet. There's absolutely no doubt, because there's very little tessellation content that exists in the world, and we had to invest a great deal, both in terms of transistors and architectural time, to make this big investment. But the point is, we want to give the developers a chance to really kind of go to that next level.
Right.
So and it's.
I guess I want to interject that one of the things I haven't said much about it, but in GF100 we actually the implementation of the geometry shader in GF100 is dramatically much more performant than past implementations. So it's also kind of in this context of a geometry pipeline, it's a very, very usable element, perhaps much more so than in the past. So let's, if there are no other questions about this, let's keep going. So, I queued
You're
myself
just
up.
drinking for yourself.
Well, okay, so I don't actually remember the slide sequence. This is a Microsoft, just to make excuses for the really crappy image quality. This is a Microsoft SDK sample. I like folks at Microsoft. I spend several hours a week with them. But this is one of their SDK samples. It's basically using the geometry shader to render the faces of a cube map, so you can place an object into a dynamic environment. So you don't have to have a static cube map, you actually generate the cube map on the fly. And it used to be that people would basically render each face of the cube map, basically doing multipass from the CPU, but with the geometry shader you can actually just do it all in one pass. And what we're seeing, again, sort of relative to 5870, we're between 4 and 5 times the performance. Now, I believe it's pretty public and well documented that their implementation of the geometry shader spills data to memory, whereas in our design, in our current design and in our original design, we chose to keep all of the data on die and manage the amplification that geometry shader has. And you can kind of see our initial implementation was regrettable, but the current one is really great, and you can kind of see the fruits of managing the data and keeping it on die. So, and actually, some of my best friends work at ATI. They're great folks, and they're really smart. They're incredibly worthy adversaries in some sense. But we all make, there's lots of different choices to make in a design. You just, you choose your design point and you go.